Hey folks, today we're going to talk about percent composition. Specifically, we're working through the worksheet for you. Okay. So I'm actually going to do the problems, and you need to have a periodic table in front of you to do them. Again, this is a long worksheet, so if you find particular areas where you need help, you can jump to those. All right. We're calculating the percent composition of lithium oxide. So what we do is we look at lithium, and lithium is 6.941 grams. We have to multiply by 2 because there are two of them. And we have to take oxygen, and we have to say it is 15.999, but there's only one of them. Right? We add these together. Let's just do that one. I'll do that one in my head. 9 and 9 are 18, carry a 1, and 12, 13. And 15.999. When I add them together, I get 29.881. Now, what I need to do is I then need to take the mass of lithium, which is 13.882, and divide by the total, which is 29.881. And I have to take oxygen, which is 15.999, and do the same thing with it, and divide it by the total. Right. Now, sorry, I need to multiply these by 100%. That's where you find percent composition. So, this is going to be 46.46%. And this one down here is going to be 53.54%. If I take my percentages, I add them up, I get 100%. That's what I want to make sure happens. It's a good way to check my work. Okay, so that's it for number 1. All right, what's the percent composition of a carbon-oxygen compound, given that a 95.2 gram sample contains 40.8 grams of carbon? Right, so we're going to go, and they've already done a lot of the work for us. Carbon is 40.8 grams. And I have to divide by the total, which is 95.2. And oxygen is 54.4. And I'm dividing it by 95.2. Right? And again, I multiply by 100. I'm not going to show the multiply by 100 because frankly, I don't do it. All right? When I do it, I do the one times 100 in my head, because this gives me a decimal and I multiply by 100. So it's 42.9%. And this is 57.1%. Again, they add up to 100. Okay. What's the percentage composition of N₂O₄? Again, you're given the information here of what elements you have, and nitrogen is 14.007, but there are two of them. You have to multiply by 2, and you get 28.014, and I have to take oxygen, which is 15.999, and I have to multiply it by 4, or 63.996. I have to add those two numbers to get up my total, which is 92.01. Right, and then what I do is I have to take each one of these, and I have to divide each one of them by 92.010, multiply by 100, and it's going to give me 30.4. Go down here. Nitrogen is 30.447%, and oxygen is 69.553%. All right, let's go on to number 4. What's the percent composition of a compound made up from 28 grams of nitrogen and 32 grams of oxygen? Well, let's look at nitrogen. Nitrogen is 28 grams. Well, remember I have to add these two things up. 28 plus 32 is 60. So I take 28, I divide by 60, multiply by 100, and I do the same thing with oxygen, which is 32 divided by 60 times 100. And my answer here is going to be 47%. My answer to this one is going to be 53%. Again, they add up to 100% just to check my work. percent composition. All right, let's keep going. We have a carbon-hydrogen-fluorine compound, so I'm going to have to do this 3 times. So I have carbon, which is 7.2 grams, and I have fluorine, which is 11.4 grams, and I have hydrogen, which is 1.8 grams, and I have to divide this by the total. So when I calculate my total, it comes out to be 20.4. If I add those 3 numbers together, it comes out to be 20.4. I multiply by 100. Multiply by 100, and that gives me yes, I did that right. Sorry, I'm looking at my notes. Right, this is 35%, and this one is 56%, and this one is 8.8%, or about 9%. Okay, and then that way they add up to 100%. Find the percent composition of Na₂SO4. Well, there I'm given all of the chemicals, so I have to figure them out. Na is 22.990, but there are 2 of them. And sulfur is 32.066, and there's 1 of them. And oxygen is 15.999, and there are 4 of them. Okay, so I go through this entire thing and add them all up, multiply them out. I get 142.042 grams per mole. Right. Okay, so now let's take each one individually. If I take sodium, and sodium I have 22.990, I've multiplied that by 2, so I get 45.980. And for sulfur, I only had 1 of those, 32.066. And for oxygen, I had 4 of them, so that's 63.996. I divide each one of these by my total, which is 142.042, and I do that for each one. I multiply each by 100, and this will give me my percentages. My percentages are 32.37%, 22.58%, and 45.05%. And again, when I add them up, I come up to 100%. Now, this one. Oh, I taught you how to do this. This one, what you really need to do is start applying information that you know. Right, so this one's going to take a little bit more work. I start with 60 liters of nitrogen. Well, that doesn't give me mass, but I can get there. I can start with 60 liters of nitrogen, which is N₂. It says nitrogen gas. And I have to get rid of 22.4 liters of nitrogen gas and go to moles of nitrogen gas. But I don't want moles of nitrogen gas. I want grams of nitrogen gas. So I can actually get some information that I can use. 1 mole, how much does N₂ weigh? Well, 14.007, weighs 22.014. 28.014, sorry. Okay, so I multiply that out, I divide, and I get 75.0 grams. Now, how about the other one? I'm given 180 liters of oxygen, so I've got to do the same thing there. 180 liters of oxygen. Oxygen is, hydrogen. My bad. Hydrogen gas of H2. And I go to do the 22.4 liters of H2 and go to moles of H2. But I don't want moles of H2. I want to go to grams of H2. And again, each hydrogen weighs 1.0079. So that's 2.0158 grams of H2. I multiply this out, and I get 16.2 grams. Aha! Well, now what I have to do is add these two things together, and that will give me 91.2 grams total. So now I can actually do my percent composition, which for nitrogen is going to be 75.0 grams divided by 91.2 grams. And for hydrogen, it's going to be 16.2 grams divided by 91.2 grams. Multiply each one by 100 because we like percentages to be numbers that are greater than 1. Right? And when I do that, I come up with 82.2%. And down here I get 17.8%. And they add up to, guess what? 100%. Alright, last one. Find the percent composition of a compound formed when 0.4 moles. Oh, moles don't do us any good. We need to have grams, right? And we need to have grams from this. We have atoms, we need grams from that. So we're going to have to do a lot of work with number 8. Right. So I start with 0.4 moles of potassium. And I have to go from moles of potassium to grams of potassium. So I have to look up grams of potassium, and that's 39.098 grams per mole. Right? When I multiply that out, I get 15.6 grams of potassium. Our next one is 8.96 liters of O2, but I have to get rid of liters of O2, which is 22.4 in 1 mole. And then I have to go from 1 mole of, what am I going from? O2, that's important, because I have to go to grams of O2. Since I'm dealing with O2, each O2 weighs 31.998. Remember, it's 15.999 times 2. When I do that math, I get 12.8 grams. So what's left? Well, I have 2.41 times 10 to the 22nd atoms of sulfur, and I have to get rid of atoms of sulfur, going O2 times 10 to the 23rd, and that's atoms of sulfur, and I'm going to moles of sulfur, but then I have to go from 1 mole of sulfur to 32.066 grams. So when I multiply all that out and divide it, I get 1.28 grams. So I have to add all 3 of these together. When I add them up, I get 29.68 grams. So for potassium, and I have oxygen, and I have sulfur. So for potassium, I have 15.6 grams. And I have to divide that by 29.68 and multiply by 100. I then have to take the next one, which is 12.8 grams, and divide by 29.68, multiply by 100. And I have to take for sulfur, I've got to get 1.28 grams, divide by 29.68 grams, and then multiply by 100. So what does this give me for KOS? It gives me 52.6%. It gives me 43.1%. And it gives me 4.3%. All right, and that's all 8 of them. Guys, if you have questions, see one of us in class. We'll be happy to help you. Have a wonderful day. Take care. See you then.